Class period will be done pretty early, pretty quickly. So 9.4, is there any questions you came across on 9.4? Number 9. All right, so number 9 and 9.4. So that's 160 degrees right here, right? If these chords are the same, you should have a center here. That means that this and this have to be equal to each other as well. So if you called this x and this x, that would be 2x. That's supposed to be an x. 2x plus 160 equals 360. So 2x equals 200. So x equals 100. So then segment xy would be 100 degrees. Angle x, which is that, would be 80 degrees because it's half of that. Angle y would be 50 degrees and 50 degrees. All right? What else we got from the homework? I was helping one of you, I think, with number 8, and I think I goofed it up. Because I didn't see the 50 and the 70. I thought they were the same. I think I just saw one of the 50s. So if your answer is wrong to the back one on number 8, I did it wrong. Yeah?
Okay, so how do you differentiate the ones where it's half of the arc and then the ones that's the same as the arc? Do you know what I mean?
If the angle is, the corner of the angle is on the circle, it's half of it.
Oh.
If it's a central angle, it's equal to it.
Okay.
Anything else from the homework? Okay.
You do number 12.
Yeah. Number 12. Call that 10x minus 20, and then they call this over here 5x plus 13. All right, so the 10x minus 20, that's going to refer to this angle here as a 90-degree angle because you're talking about a tangent line. A tangent line to a radii is always 90. So I get 10x minus 20 equals 90. 10x equals 110. Is that right? 10x equals 11. Did I do that right?
I did minus plus.
I forgot what this asked for. Find x. We found x. And then find segment AB. So then we're looking for this right here. So I'm going to take that 11, plug it in. So I get 55 plus 13. So plug it in there. So that's what, 68? Any other questions from side 9.4? Yeah. 16. I didn't realize there was a problem there. The answer's still on that. All right. Tangent there. This is the center. This here. M. N. P. L. Q. All right, so they tell us this is 15 degrees here. This is 20 degrees over here. All right, so they want us to find LP. So they want us to find this segment right here, correct? So things to know, this is a semicircle. This is half the circle down here. So if this is 15, then this has to be 30, right? And the distance all the way around is 180. So I get 50 of that already, so that has to be 130. Okay?
Thanks, bro.
And then MLP. MLP. So this angle here, well, if that's 20, that has to be 10. So that whole angle then has to be 25 because 10 plus 15. And then PLQ. PLQ. So you're looking for this angle here. Well, that's tangent, so that has to be 90 degrees. That's made up of a 10 and a 15 in this. So I have 90 minus 25, which is 65 degrees. Is that right? All right? Anything else? Bag of chips?
You didn't tackle John because of a bag of chips.
I thought it was unbelievable. All right, if you would, make sure your name is on that assignment. Pass it on forward, please.
I think you have some internal anger issues.
He's got more inhibitions than I do.
Dude, that's scary.
That's hard.
Nothing wrong with that.
Now, you know what?
I don't think of a reasonable reaction. You just like.
Absolutely. Everybody else got homework? There's some more. All right. So.
No, yeah. It was like this was like we're like a graph.
So yesterday.
For a pie chart, it'd be like this is us and then like this is you, but you were like all of this.
Yesterday. Those of you might know this. Here's West Middle School. Still with me? So this is Bellevue, right? And this is what, Colorado? Holly. Holly. So, starting about here, you have a flashing school zone. And about here it says end of school zone. So, this region here is the flashing school zone speed limit. Still with me in the story?
Yeah.
So, I'm driving home. And as I'm traveling west to go home, there's a lane here. You know, I'm not worried about the turn lane. A second lane here. And then you have the right turn lane here that, you know, if you were to go from Holly and turn, you could do that. So, this real smart guy, not me, I'm like right here. This dude decides I'm too cool for a school zone and does one of these. Crosses here. And guess who was on this fancy motorcycle right about here? It was hilarious because, you know, the guy, he just blasted by and he's kind of like one of these, you know, looking at everybody who's doing the speed limit because he's too cool for it. So it was a while before this motorcycle cop got right behind him. So me and the guy that was next to me slowed way down as we got next to him. We were honking our horn going, hey, look at you, number one. And he told us we were number one as well. But he was using a different finger than we were. It's kind of funny. But I didn't get a ticket. I thought it was hilarious. It was like, man, you know, I'm sorry, guys and girls. I realize that when you're driving, the patience with people stinks. And the patience with, I have to go this slow because I know it stinks. But I tell you what, sometimes it just pays off, in my opinion.
Oh, yeah. And you're going like 3 miles above the speed limit or something,
Yeah,
and they're
it's
still riding you when you're driving and
I'd be lying to you if I said I wasn't.
I crossed it, you know. And some guys,
I feel like you drive like a decommissioned fire truck.
No.
Like you drive like a 19 and it's like painted all black, but you can still obviously tell it's a fire truck. It's like
I always need something to do with my hands.
That was fun.
That'd be sick.
My daughter is into
Shag shack.
making slime.
Yeah.
The white glue and
Okay, I get it.
It's a mess sometimes. But if you stay in one spot, then it's
all right. In 3, 2, 1, ready?
I like this part.
Y'all ready for this? 12 for 3. All right, half hour. Here, given circle O has a segment of 24. AB segment is 24. Okay, so right here is 24, right? Did I do that right?
Yeah.
So I have this segment here 5, this segment here 5, a radius that I don't know. This is also a 90. But what are some things that we can start concluding off of this distance right here, you think?
It's the same
Well.
as GE or EC.
So that's 12 and 12. And that would be 12 and 12. And then I have another radius right there, another right angle. So is the 5, 12, 13 a right triangle that might exist? Okay. I don't even know what we need to find here.
DE.
DE.
Ah,
Bless you.
Jesus.
You found everything.
I did?
Yeah.
Yeah, you did.
Oh, sweet. DE, sir. Oh, yeah,
Bro, what are
sweet.
you doing?
Yeah, we answered everything just by going through. And that's pretty easy, I thought, maybe. All right, objective. Derive and use properties about inscribed triangles and inscribed quadrilaterals. Inscribed polygon, a polygon with all of its vertices on the circle. So all the corners would find their way onto the circle. A circumscribed circle, this is the circle that contains the vertices of the inscribed polygon. So it looks like they have a pentagon drawn there. It's an inscribed pentagon because the corners or the vertices of the pentagon all happen to lie on the circle. The shape does not have to necessarily be regular in order for this to happen. But there are some rules that will come with it. Feel okay so far?
Yeah.
Am I teaching well?
Yeah.
For a Friday on a goofy day? All right. Consider a right inscribed triangle and circle. What is the measure of ADB? What is the measure of this? And I heard 180.
You don't know that.
Yes, it is.
Wait. Oh yeah, 'cause
It's written on.
It's what? It's already written on? Oh, okay.
I'm done.
So let's decide why it would be 180. If this is a 90-degree angle, and this is an inscribed angle, right? And it opens up, that means that its arc length that it opens up to has to be double it. Oh. So if that's the case, this must be the center of the circle. Because that would be a diameter. Would that be okay? Okay, with respect to the circle, what type of segment is AB? Oh, it's the diameter. It's the longest chord. Does everyone see why we would say that? Because we're talking about a semicircle in this case. We know that the arc length is 180. That's half the circle, bless you. Half the circle means that endpoint to endpoint, bless you.
You don't have to exaggerate it like that. Okay, we get
He's
it.
not exaggerating it.
Oh no, he definitely is.
No, I'm telling you, I sneeze like that too.
Don's really
Thank
sneezing
you.
so much.
People hear me in the next county.
understands me instead of this big-headed dude in front of me.
His real sneeze sounds like a dying chipmunk.
Alright. Alright, we just proved the new theorem. Ta-da! Right triangle is inscribed in a circle if and only if the hypotenuse of the right triangle is the diameter. So that's theorem 9.9. That's what we just proved. So a right triangle is inscribed in a circle if the hypotenuse of the right triangle is a diameter. Pretty easy. May I move forward? I don't even know if that was written down for you. Yep. No. On the backside. Woo! Going fast. All right. Consider a quadrilateral as inscribed in a circle. Shh. So measure of ABC. So ABC, this measure here, plus ADC.
That's the arc.
Oh, okay. So, hang on.
Wait, do
Here.
the inside angles have to add up to 36 though?
Yeah.
Yeah,
So
no,
we
no,
have
like the
this.
angles
Hang on.
inside the quadrilateral.
All right. See that? That's the arc we're talking about, right? Is this a half circle or more? It appears to be more. Plus ADC.
No, no.
Wait,
You did the angle
I-
for ABC. It's the arc of ABC plus the arc of ADC.
So measure of ABC. Oh, I didn't do ABC. I did ADC first. So that was purple, right? Let's do this one in green. ABC. So if I add those two together, I get to 360. So this angle here would be half the purple, and this angle here would be half the green. So what would half the purple plus half the green have to add up to?
180.
180.
Look at that. So the inside have to be 360. Yeah.
So notice that angle B is half of ADC. We just said that. Angle D is half of ABC. So therefore, angle B plus angle D is half of angle ADC plus half of angle ABC. And half of those would have to mean that it's 180 degrees. So if these two angles are 180 degrees, these opposite angles are 180 degrees. They are supplementary to each other. And it would be the same thing for this angle over here and this angle over here. So in order for you to have a quadrilateral inscribed into a circle, so the corners of that are on the circle, the opposite angles have to be supplementary.
Oh, that's such a praise, man.
All right, we just proved the new theorem. Yay! A quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. Beautiful. All right, find angle T. So what did we just say? This angle and this angle have to add up to what?
180.
So what this must be 120 degrees. Still with me?
Yeah.
Angle U. So this angle and this angle have to add up to 180, so that has to be 80.
Yeah.
That was easy.
17y plus 19y equals 180 and the same.
What? So you're out of control again.
I was right though.
All right. 17y plus 19y equals 180. I know, but
36. I'm sorry.
so y is 5. Love it. And then 5x plus 7x equals 180 as well.
12x.
12x equals 180. What does that come out to?
Like 16.
16? I'll go with that. Is that really?
Yeah.
Sweet. All right.
Oh wait.
No.
No.
1, 65, 15. 15. There we go. Shh. Almost done.
Yeah.
I think. Where am I?
Yeah.
Yeah, you are.
Dude, you kidding me? This class is almost done.
No, you got like, I wish.
19.
No, you probably got 20 minutes left.
Works for me. All right. Find x and y. We have circle O. So
Pythagoras.
this
You don't know.
this is a right triangle. Do you agree? Why do I know it's a right triangle? That's the diameter, so that's a 90-degree angle. So 10y equals 90. So y equals 9. And then these two angles need to add up to what then? 180. So I get 2x, 3x is 5x. 5x equals 90. So x is equal to 18.
Wait, why 90?
Oh, because the other.
Because the other two angles. If this is a 90-degree angle, then this plus this has to be 90.
The two have to
We-
add up to the right.
Right. How do I feel about time change in school? If it is best for kids, I'm always for it. That's my philosophy of education. If it's best for kids, we need to do it. Now, is testing best for kids? So guess what I'm not a big fan of.
What about homework?
Homework? No. Homework in my tests, things that are related to the courses are fine. But the standardized testing, where part of the testing procedure is if you have a child vomit on the test, this is the protocol that you use. There's something wrong with that.
No.
Yeah, they're overrated.
Wait, seriously?